Hello everyone, welcome to Pepcoding. So today in this video we are going to discuss a question that is path in zigzag labeled binary tree. So what is given in this question? Let's discuss just this line first. This line. What is this line saying? That in an infinite binary tree where every node has two children, the nodes are labeled in row order. Okay, so what this is saying? Let's say let's take this tree as an example. What it is saying, that if we are or let's make our own new tree. If we are provided with n is equals to 10, then the nodes are labeled in level order, right? So 1 2 3 4 5 6 7 8 9 10, right? So the first line means that in the infinite binary tree, if n is given to us something like this 10, then our tree is going to be something like this, right? This means that every node is ordered or labeled in level order. First 1, then 2 3, then 4 5 6 7, and then 8 9 10, right? This is the first thing given to us. Now second thing given to us is that it is a complete binary tree. First thing was infinite finite binary tree. Second thing that is given to us in this question is nothing but the tree is a complete binary tree, right? I'm just going to describe you the question really quickly so that you will be able to understand more easily. So we know that what is mean by complete binary tree. The complete binary tree means that if, let's say, there is 1 2 3 4 5, this is a complete binary tree, but or let's say 8. Okay, this is a complete binary tree, but this is not a complete binary tree. What? 1 2 3 4 5 and 6 here. This is not a complete binary tree. You can say that instead of writing this here, you can say that this is a complete binary tree, but this is not a complete binary tree. Why this is not a complete binary tree? Because according to the definition of the complete binary tree, we know that the all the nodes should be occupying cells, that is starting occupying the positions of children starting from left side to right side and not skipping any values. What I am trying to say is that here we can say that 1 is having two children, that is 2 and 3. 2 is having two children, that is 4 and 5. 3 is having one child, that is on the left side, not on the right side. Here 1 is having one child, but this child is still missing. Therefore, it is not a complete binary tree. So these two things are given to us. Now let's move towards the question. What this question is saying that what this question is saying that we are provided with a binary tree. If this is visible to you, just bring it here. Okay, so now what we are told to us, or what is given in this question, the question is saying that this is the provided binary tree to us. If we see that this is a normal binary tree, if I make a complete binary tree or infinite binary tree for n is equals to 15, it is going to look something like this. This is also a complete binary tree and is also a labeled binary tree. You can see that here for n is equals to 15, there is 15 present, which means that there are 15 nodes and everyone are occupying the correct positions in the level order, right? If I say just in the reference of the nodes, right? But what is the difference between these two? The difference is that this is in this order, this is in this order, this is again in this order, and this is again in this order, right? So this is the difference. Now let's see. First, let's forget about this question, or let's forget about the current question. Let's try to discuss same question on this tree, right? Let's not take this tree in consideration for now. Let's say the question is saying that if I am provided with an integer n, for this question we will be provided with a single integer n, and we will not be provided with anything else other than this. That is, we will not be having a tree or we will also not going to construct a whole tree and then going to do something, right? So here currently we have just one integer, that is n. Now it is saying that if it is a infinite tree, then find the total or find the path to reach n. What I am trying to say, let's take this 13 into consideration. Let's say that it is saying that if I am currently standing here, right, I have to find the whole path to reach 13, that is 1, 3, 6 and 13, right? It is saying that return me this path as an answer, or it is just saying that if a number is given to you, then find the root, or find the node to root path, that is find the node to root path in the infinite binary tree. So if I was provided with this infinite binary tree, or if I was provided with this tree, it was really easy for me to find out. That was we can just use that algorithm, that was of find node to root path, right? We have already seen this in the previous videos, right? We can use this, but currently we are provided with what? With nothing but just an integer n, that is, let's say, just 13. N is equals to 13. We are just provided with n is equals to 13. Now we have to find what? We have to find path of 13 from 1, that is 1 is the main root node, 0 is not the main root node, but 1 is the main root node. This is one observation, right? Now our answer should look something like this. Now let's try to think that how we can achieve this answer. Currently we are not we are discussing a little part of the question, that is we are discussing on this tree. Further we will be discussing, the question is going to remain same, that if I am asked to find 13, that is I am asked to find the path of 13, I have, and the tree is given in something like this order, that is the levels are interchanging at every even level, like this, that is first it was 1, then 2 is here and 3 is here, but in our normal tree it is going to be something like this, 1, 2, 3. Then what is going to be path? What I am trying to say, that the question is saying that we are provided with 13 and we have to find the path in this tree. We have to find what? The answer is going to be what? The answer is going to be something like this, 1, 3, 5, 13, right? Here 1, 3, 5, 13, and answer here is 1, 3, 6, 13. So we can see that this 5 is being interchanged, or this 5 is being replaced with something else, right? So for now let's not discuss this, let's discuss this only, that how we can achieve the solution. Now let's think that if I am currently standing at this 13, somehow I was able to get the value of 13's parent, right? Somehow I was able to find parent of 13, then that is going to be what? 6. Then can I include this in my answer? Yes, I can. Similarly, if I'm standing at 6 and if I try to, or if I somehow got the value of 6 parent, that is, who is the parent of 6, then that is going to be a valid path, that is going to be included in my path, that is this, right? And somehow I was able to get the value of parent of 3, then that is going to be my answer. And if terminating condition is just going to be, if my answer is containing 1, that means I have reached to 1, then terminate from there, that means that is going to be my answer, right? Currently now we are thinking from where? We are thinking from bottom to top, right? So let's write this, let's try to formulate this, let's try to create a formula, generic formula for this. If I say that if I somehow get the parent of 13, parent of 13 is what? Parent of 13 in the general tree is going to be 6, right? Now how we can achieve this? If I say that, if I observe this, that 13 by 2 is nothing but 6. Why? Because in integer values it is going to be 6, it is not going to take points, right? And 6 by 2 is nothing but what? 3, and 3 by 2 is nothing but 1, So if you observe carefully, this 1, 3, 6 are included in our answer. So but that is going to come like what? First 13, then 6, then this 3, then 1, which means I am trying to jump to his parent, that is 13's parent, that is going to be 6, then 6 parent, that is going to be 3, right? And then I am going to reach to 1. So I am going to get my answer something like this. And what I have to do, I have to just reverse this. So that is going to give me my required answer, right? So from this thing, from this thing can I formulate, or can I derive a formula that here in this general tree, parent of n is nothing but n by 2, right? This is one formula. Can I say this? Yes, this is actually working from this will actually work for every node. Let's say for 11 it is going to be 11 by 2, it is going to be 5 by 2 it is going to be 2, and 2 by 2 is going to be 1. So this formula is going to give me the total path for the given node to 1, right? And I have to do what? I have to just reverse that. So this was what observation? This was observation for a general tree, a normal tree, if the tree is given in the proper order, like 1, 2, 3, 4, 5, 6 and all. Right. Now let's try to discuss for this thing. Let's try to apply the same formula. First, let's try to apply the same formula for this thing. What is the difference between these two trees? I have just told you that this tree is first order is given in this direction, that is left to right, then right to left, then again left to right, and then again right to left. So how to find answer for this? We have already seen the difference between the answer, right? One is going to be constant, and third, the answer or the node that we have asked is going to be constant, right? Why? Because one is our terminating condition, one is the head node, so we have to find the path from one to the given thing or the given node, right? Now let's try to put this formula, or try to apply this formula here in this tree. If I do this thing, if I do 13 by 2 here at this position, 13 by 2 is going to give me what? Is going to give me 6, right? This means that parent of 13 should be 6, but in this tree, as we can observe, that parent of 13 is 5, not 6, right? Let's do the apply the same formula further. If I divide 5 by 2, it is going to give me what? Parent of 5 should be what? According to this formula, parent of 5 should be 2, but here it is giving me 3, right? So here we can say that this formula is not working at this place, right? This formula is not working on this general tree or this given tree, right? That is the orders are in different order. The orders are going to be what? Going to be interchanged. That is, first it is going to go from left to right, then it is going to go from right to left, right? As I have written here. Now then, how to find the formula, or how to find this, how to find a relation that is going to give me something like this? For this question, this tree, we are able to find a relation. Now how to find a relation for this tree? Now here comes the comparison thing, like we are going to compare these things. What we are going to do, and I'll just first erase these things, it will look more neat. Okay, this is what? This is T, right? So now let's start comparing these two trees. If I observe carefully, let's start from this level, right? Let's come from top to bottom. Let's go from top to bottom. If we compare this tree with, or this level with this level, what can we observe? Can we see that at the position of 3 in this given, or in this general infinite tree, there should be 2, and at this position, at the position of 2, there should be 3. Okay, this was the first observation. Now this level is here it was 6, so yes, this level is as it is, so let's leave that level. Let's go to the next level. You can see that at the position of 15, what value is coming? Value is coming 8, and at the position of 8, in this tree, in the given tree, at the position of 8, what was coming? 15 is coming, right? Similarly, if we look for this 12, at the position of 12, what is coming? 11 is coming, and at the position of 11, what is coming? 12 is coming. So if we see, or if we observe this thing, can we see that, or can we say that the values are being interchanged with the original values from this general tree or from this infinite normal tree? What I am saying that, can I say that at this position of 15, actually which value is going to be there? 8 should be there, right? At the position of this 8, 15 should be there, right? In the according to this tree, if I compare these two trees, at the position of, let's say, 12, 11 should be there, and at the position of 11, 12 should be there, right? These are the two things what I can say. So from this thing, can I now formula, or can I now derive a formula? Let's call it as a complement. Let's call it as complement. What complement? What I'm trying to say is that, let's call that complement of 15. Complement of 15 is nothing but what? 8, right? Complement of 15 is nothing but 8. Let's try to find for 13 only. If I say that complement of 13 is nothing but what? Complement of 13 is nothing but 10, right? That is, I am doing what? I am just comparing this value with this value. That is, instead of this 13, what should have come here? It should be 10, right? And if somehow I put 10 here, or somehow I get value 10 for this 13, I can easily get its parent, right? What I am trying to say is that if I get 10 here, then 10 by, this formula is now going to work. That is, 10 by 2 is nothing but 5. Instead of the at now, if I compare this 5 with this tree, 5 was going to be 5. So now if I compare this, if I do this, what? 5 by 2, what I am going to get? I am going to get 2 as an answer. But here, what was coming? 3 was coming. So, but if I do complement, that is, complement of this 5 is what? This 5 is this 5, right? This is going to be replaced with this. If I get this as in value, and if I now divide it, answer is going to be 2, right? And similarly it will go on. So what I am trying to say is, sorry, what I am trying to say is that if somehow instead of this 13 I am able to put value 10 here, then I'll be able to achieve this 5, right? So what I am trying to say, if I write this as complement of 13 as 10, then what I can do, what will the formula that I can derive as? Parent of 13, or parent of n, let's say this 13 as n, is nothing but its complement of n by 2. Let's try to put this formula at the place of 13, then you will be able to understand more clearly. Parent of 13 is nothing but complement of 13 is what? Complement of 13 is 10, as we have just looked. By 2 is nothing but 5. Answer is coming as 5. Now let's put this 5. Parent of 5 is nothing but what? This complement, that is 5 by 2. It is 2. Or instead of this 5, let's try to look for this. That is, because this level is going to be same, so therefore no need to change. Let's try to look for 9. Parent of 9 is nothing but what? Parent of 9 should be what? 4. So instead of this 9, if I am able to get value 14 somehow, then what it is going to be? 14 by 2. It is going to be what? 14 by 2 is going to be 7. So here you can see that value is 7, and our answer, if I declare the 14 as this 7, right? Here we are getting the 7 as the answer, right? Parent of 9 is 7. Previously what was happening? Previously it was happening that if I just do 9 by 2, I was going to get what value? I was going to get 4 as the parent, but here 4 is not the parent. Who was the parent? 7 was the parent. So therefore we can say that this formula is working for this. This formula is valid to get the parent in this given tree, right? Now if we are able to get the parent's value, then then how to find this complements value? That is, if I am going to get this, I'm just going to get an integer n is equals to, let's say, 13, and find me the path from 1 to 13. Then how to find the path? Like, I am saying I have derived a formula, that is, if I know the complement, I'll be easily able to find its parent, and then I'll be able to easily get the answer. But now, how to find this complement? How to find this 9? As if, or as what I'm saying is, how to find the complement of 13. So there should be a relation again. Let's try to find this relation. Let's take it here. Okay. Okay. Now, if you observe carefully, again, if we take the reference of this tree, that is the general tree, if I consider this as a starting point and ending point, right? Initially at level 0, it is going to be same. At level 1, what is going to be there? Starting point is going to be this, ending point is going to be this, starting point is going to be this, ending point is going to be this, starting point is going to be this, and ending point is going to be this, right? I'll just erase this, right? Now, here, if I try to determine that how the starting point and ending point is going to be, if I'm saying that 2 is starting point and 3 is ending point, I'm going to apply the same thing here. What I'm saying is, starting point and ending point is going to be common for this first value, that is at level 0. Starting point and ending point is going to go starting point here, ending point here, again starting point here, ending point here, again here what starting point was 8, so I'll put starting point here, right, and I'll put ending point here. Now if you observe carefully, what is happening actually, starting point and ending point are getting interchanged at every even level. All right, now how to find out the starting, let's first discuss for this tree, then we'll go to that tree. How to find the starting index and end index for this level or for this tree, right? For at every level there is going to be a new starting point and new ending point, right? So how to find that? If it is a complete binary tree, then can I say that if this is level 0, this is level 1, this is level 2, this is level 3. If we observe carefully, can I say that starting point is nothing but what? Starting points are what? 1, 2, this 4 and 8. These are nothing but 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, right? This is 1. These values are equal, right? So can I say that 0, 1, 2, 3 are nothing but our level? So can I say that 2 raised to the power 11 is going to give us our starting point? And also we can say, call it as nothing but last level value. That is, in this level, the in this in the exponential form of 2, that is perfect square or perfect cube, what is going to be the perfect square in this level of in this level? What is going to be the perfect square of 2? It is going to be 4. In this level it is going to be 8. So can I call this as nothing but starting point is equals to 2 raised to the power level, or I'll just call it as last level value. Here you can see that value of last level is nothing but this is 4. That is the last perfect exponential value of 2. This 8 is nothing but in this level, that is going to be the last perfect exponential value, right? So can I say, first we have derived this, that is 2 raised to the power level. This is going to be one formula, and we just nomenclature it with nothing but last level value, right? Now let's try to find out some relation for ending points. What we can see here, if I say like 7 is my ending point, let's take 7 as an example. If I say that 7 is my ending point, then how to find the relation in this ending point? Can I say that, or can we observe that summation from 1 to n is nothing but our ending point? Let's see if it is true or not. If I say that n is equals to 7, then from 1 to 7, that is going to be nothing but our ending points. Let's see, 1, 2, 3, 4, 5, 6, 7. Or instead of summation, summation is not sounding correctly. Instead of this summation, what we can say that for binary trees, what we can say that summation of 1 to n nodes. 1 to n nodes. So here you can say that 1 node, 2 node, 3 node, 4 node, 5 node, 7 node, 6 node. Actually, it is nothing but summation of 1, 1, 1, 1 till n. But now it is in complete binary tree. And we know this property that for complete binary tree, summation of 1 to n is nothing but what? As if you know, or if you are able to recall, it is nothing but 2 into n minus 1, right? This is going to sound more clear or sound more easy. So if I say that ending point is nothing but 2 into n minus 1, let's try to say if it is going to be true or not. Let's take this 11 as an example. If I say that n is equals to 11, then if we are finding the number, the ending point for this 11, let's try to put this in the formula. Ending point is nothing but 2 into 11 minus 1. That is going to be what? 22 into sorry, actually here I said something wrong. This n is not going to be 11. This n is going to be the number of nodes in that level. Okay, this is what I was saying wrong. That's why the formula was not implementing, because what we did just this 11 minus 1, that is going to give us what? 22 minus 1, that is going to give us 21, and 21 is nowhere in this whole tree currently. So actually this n signifies what? The significance of this n is nothing but number of nodes in that level. And we know that how to find the last we know that the last level value is nothing but the starting point, right? So for the now let's try for this 11. Now let's try for this 11. If I say that for this 11, find the ending point. If I am currently standing at this position and I don't know that at which level I am currently standing. So how I am going to find out? I am just going to find out that 2 into, or let's say 2 raised to, what is the level? So if I can see that this 11 is nothing but this 11 is nothing but smaller than 2 raised to the power 4, but it is greater than 2 raised to the power 3. And we know that this 2 raised to the power 4 in this general tree is nothing but the starting point. So obviously this 11 is not going to be included in this tree. So therefore it has to be included in this part, that is from 2 raised to the power 3, that is in the level of 2 raised to the power 3. So here we know that the level is nothing but 2 raised to the power 3, that is going to be 4 into 2, that is going to be 8, right? So we can say that the total number of, or not the total number, but we can say that last level value is nothing but 8. I hope you are able to get this thing, that how I found it that 11 in which level 11 was standing. What I said that, let's say again I'll do this, and this time let's do this for 15, right? Let's do this for 15. If I say that I am given just 15, then I have to find what? First I have to find its level, right? First I have to find its level, and after using this level I am going to use this formula to find the ending point. First I am going to find the starting point, then I am going to find the ending point. Now for this we know that 15 is not going to be, or 15 is less than 2 raised to the power 4, that is 16, and it is greater than 2 raised to the power 2, 2 raised to the power 3, that is nothing but 8. So can we say that this 15 is going to be included in that level where 8 number of nodes are present. See, here you can observe that for every level, how many number of nodes are going to be there. Let's see that for this level there are going to be two number of nodes, right? And this 2 is nothing but our last level value, if that is are going to be starting point. In this level there are only going to be 4 nodes, 4 5 6 7. There are going to be 4 nodes, and this 4 is nothing but our last level value, that is nothing but our starting point. For this there are going to be 8 nodes, and starting point is going to be 8. So from this we can say that now if we are able to relate from this, we are able to say that starting point is nothing but last level value. And now if I am able to get the level, that is this 15 is going to be added, or this 15 is going to be included in level where there are going to be 8 nodes, right? With this, what I was able to find, I was able to find the last level last level value, that is nothing but number of nodes in the in that level, right? Number of nodes in that level. So if I now put this in, that is last level -1. If I not put this in formula, I am able to get my ending point. I know this is going to be this is getting a bit confusing, but if you just go back and watch this again, then you will be able to understand. There is nothing but a simple formula derivation, and I guess that you will be able to derive this on your own only. So here that is going to be nothing, 2 into last level is 8 minus 1, that is nothing but 16 minus 1, that is going to be 15. So here ending point is going to 15. So for this 15, or for this 11, or for this 9 10 11 12 13 14, 15 is going to be the ending point and 8 is going to be the starting point. So from this we are able to derive two more formulas. Those formulas are nothing but, first, starting point is nothing but last level value, and ending point is nothing but 2 into last level value minus 1. These are two more formulas. Now we have did this much of thing, that is we have did all this work for what? For one simple reason, that is to find the complement. How to find the complement? Now I'll explain you that how to find the complement. If I am able to get the starting point and the ending point, that is if I am able to get the starting point and ending point, let's call it as ending point, let's write here at starting point, and this n is given to us, right? And we know that complement of this 13 is nothing but it is going to be this 10, right? Let's call it as x. Now if I don't know that where this value x is lying actually, then can I say that if I am able to, if we observe carefully, this 15 is having its level here or its complement at 8, 14 is having complement as 9. So if we take 2 pointers, these two are actually at equal distance. What I am saying is that if from this 15 the given n is at, let's say, y position, or let's say a position, then from this starting point the complement should also be at a position, right? Which means that these two distances are going to be same. If we see for this 14, and if we keep this 12, sorry, if we take this 14 as an n, then its complement is going to be what? Its complement is going to be 9, and distance between these two is what? Of one node, or let's say of 1, then these two distances are going to be equal. So I hope that this distance thing is clear to you all. Now if we use this thing, that is if we use these 4 pointers and relation between these 4 pointers, how we are able to get the answer? Can we say that end minus n is nothing but x minus starting point? That is if I subtract this distance, that is going to be equal to that distance, that is it is going to be 0. If we say, or not 0, but the distance between these two is going to be equal, right? What I am saying is, if we did this, we know that the distance is same, therefore if we did this, we are going to get the equal answers. and this x is nothing but what? This x is nothing but our complement. We can see here that x is nothing but complement of 13, and what our motive is? Our motive is to find the complement of n. So if I do this, x is equals to nothing but ending point plus starting point minus n. It is going to give me what? It is going to give me complement. And now we have already derived these two things, that is starting point and ending point. Let's just put this in our formula. Then our formula is going to look something like this. X is equals to, ending point was what? 2 into last level value minus 1, right? And starting point was nothing but our last level value. So it is going to be plus last level value and minus n. That is nothing but x is equals to 3 into last level value minus n. So this is going to be our final formula. So with this formula we will be able to get exponents, and what we have to do after that we have to component, and what we have to do after that, we have to just divide this complement by 2 to get the parent of n. So in short, what was the whole story? What we did actually, I'll just go through quickly. First, we created this normal general tree. We derived a formula to find the pattern, find the parent of the given n. That was nothing but n by 2. In this particular thing, or in this tree where the level was interchanged, or the level at every even level was changing, that was from right to left, then left to right, right to left, left to right. That is in zigzag way, as according to the given question. We derived a formula that if somehow I am able to get the complement value of this given n, that is the original value, that should be present at this particular position in the given original tree, that is in the given correct tree. If I am able to get that complement value, and if I divide it by 2, I'll be able to get this answer, that is I'll be able to get the parent, right? This was our first thing. Now to get this complement, what we did, we put some starting point and end point, that is the same thing. We had a starting point, we had the ending point. We know that if n is given to us somewhere like this, and it is having some distance a from the ending point, then the same distance is going at the same distance from the starting point, our complement is going to be present, right? So we did this thing. Now we have what? We have the complement is nothing but our end point plus starting point minus n. Now how to find the starting point and end point? We have seen that to find the starting point, what we see that starting point is nothing but last level of this particular last level value, that is nothing but 2 raised to the power level. What this 2 raised to the power level or last level value means is that in this level, at this particular level, how many number of nodes are going to be present. That is the simplest definition that you can see that. And how many number of nodes are going to present at any level are nothing but 2 raised to the power level. That is for this level, that is going to be at level 2, there are going to be four nodes present, right? What we are doing, we are just recalling the whole thing, that what we did, so that you will not be confused. So after getting the starting value or starting point in this general tree, what we did, we try to find what is going to be the end value, that is what is going to be the ending point. So we know that for a infinite tree or for a complete binary tree, the ending point is nothing but 2 into n minus 1. That is number of this n is going to decide this n is going to signify what? It is signifying number of nodes in that level, and number of nodes we have already found what? From where? From this point, that is last level value, that is nothing but starting point. So if we just put the starting point here, we are able to get our answer. Also, how we are able to get, if I am giving, let's say if I am given let's say 20, how am I going to decide that this 20 is going to lie in which level and how many number of nodes are going to be there? I am just going to see that this 20 is going to be included in which level. First I have to see that. I know that these levels are nothing in but 2 raised to the power something values. So if I see that, what is the next nearest greatest value or the very next value in the exponent of 2 that is going to be greater than this 20? That is nothing but 36, right? That is 2 raised to the power 2 raised to the power 5 if I am not wrong. Let's see. 2 into 2 into 2 into 2 into 2. This is going to give us 8. This is going to give us 4. And 8 4 is nothing but 32. That's wrong. This is going to be what? 32. Right? Yes. So this is going to be 32. Right? That is nothing but, instead of writing this 32, we can write that as 2 raised to the power 5. And this value is just greater to what? 2 raised to the power 4. That is nothing but what? 16. I'm saying 16, yes. And this is 32. Right? So this tells me that this is not going to be included in this level. Which is this level? This level is nothing but 5th level. Right? And but this can be included in which level? In 4th level. Right? So we can know, we are able to know that 20 is going to be included in that particular level where the number of total nodes is going to be 16 and starting point is going to be 16. That is, in this general tree, starting point is going to be 16 and number of nodes is going to be 16, right? So from this we are able to get what? We are able to get our ending point. That is end point for what? If we are able to find the level, that is the last level value, we will be able to find what? We will be able to easily find out the ending point. And using this ending point and starting point, we just put the values here. We will be able to get what? We are able to get our x, that is nothing but our exponential. I know this got a bit confusing, but if you just simply look at what we did, actually we just derived some formulas that helped us to give our exponent that helped us to give us the complement value. So if it is getting a bit confusing to you all, just write down this formulas somewhere and just watch the video again and try to correlate those things, that is those formulas, how we derived those formulas. And for better understanding or for better thing, just always draw this general tree and this given tree and try to compare these things. Actually we did nothing but we compared these two things and we derived derived all these formulas, right? So now moving forward, after getting this x, what we did, we just find the parent. We will be able to find the parent of n for the given n, and we are just going to store those parents in our answer, and we are just going to return our answer. But first we have to reverse that, right? So with this, I hope the logic part was clear to you all. Now let's do the code so that you will be able to understand more easily. Okay, here what we are provided with, as I said previously in the video, we are just provided with an integer n. There is no tree given to us. As you can see that we are not provided with any tree, right? So now what we are going to do, how we are going to start? First, let's make a variable that is nothing but our last level value, and that is going to be initially 1. Why it is going to be initially 1? Because as if you can see that, if you are able to observe that at level 0 there are how many number of nodes? There are 1 number of nodes. So initially the last level value is going to be 1. Let's declare another value, another variable. Let's name it as current val. That is initially going to be 0, right? This is going to help us to get the number, to determine that that how many levels are there, right? So what we are going to do, first we are going to run a loop while current val is less than n. Do what? Just add the last level value in this current val, and also just increase the level value, that is last level value, sorry, increase the last level value by 2. That is, until what this thing is doing is nothing but what we did here. That is, we determine the level. We determine the first. We are able to determine that in which level this n is going to lie, right? So this is doing this function, right? Now, as we are using while loop till current value is less than n, it is going to set us at one level more. That is, what I am saying is, for this current while loop, if I am saying, what I am saying is, for this n, or for this 15, it is going to land us at 16, right? And so therefore what we are going to do, we are just going to divide it by 2 and we are going to get the value, right? So we are just going to divide this last level value by 2. So what I actually did here, if you are not able to understand with this example, I'll just try to explain you. What we know that, let's place these things. We have these two values. First one is current value and second one is last level value. What this last level value is going to give us, at every level it is going to return us the value, that is the number of nodes that are going to be in this node, at this level, right? For this it is going to give us 2, then 4. If we try to look in this generalized tree, you will be able to understand more easily. Just or let's keep it here only. What I'm saying is, this current value is nothing but 0 and last level value is nothing but 1. So using this loop, what we are going to do is, we are going to see that this current given n, that is this current given n, where it is going to lie. Let's say first initially it is going to be 0. What we did, first we added the level, that is when c value is less than n, we are going to add it with the level is what, 1. So c value is going to be this 1, then it is going to be 3, then it is going to be then it is going to be 5, that is it is going to be incremented by 2 to 2. Similarly, our level is also going to be incremented by 2 to 2. So at the end, when cval reaches here, that is for this 11, let's say cval is going to be what, cval is going to be something like 15, and our value, that is our level, is going to be something like 16, because till this point, because actually it is not going to increment by 2, but it is going to increment by level, right? So at this position, cval is going to be what, cval is going to be something like this 15, and this 15 is going to be less than this 11. Sorry, this condition, this while loop is going to be breaked out. So therefore at this particular point of time, level is going to be our 16. So to reduce this, or to come back to our original level, we're just going to divide it by 2. Now let's move further. What we are going to do, we are just going to create an answer. Let's of int type, that is going to be answer, right? Now we are going to start our work, that is start finding our parent of the first component, then its parent, and we are going to add this in our answer. So while n is not equal to 1, that is n is not equal to 1. Why n is not equal to 1? We have to check for this condition, because n is our terminating point. So while n is not equal to 1, we have to do what? First we have to add this in our answer. So answer back this n, and then we have to first find the component. So let's name it as comp. And what was the formula to find the component? It was nothing but 3 into number of, or so sorry, let's say level, that is last level value, minus n minus 1, right? As we have discussed previously. Yeah. Here we can see that this is how we are going to get the complement. Now parent of this, let's name it as PR. Parent is going to be nothing but this comp by 2, right? Now n is going to be what? N is going to be this parent, and our level is also going to be decreased, that is last level value is going to be decreased by 2, right? That is going to be decreased by 2. This means that first we are able to find the parent of 13. Now we are going to we are going to take n here. Now we are going to find the parent for 5. So after this, what was this, the last thing we have to do? We have to first sort this. Sort, we are going to call this sort function answer dot begin comma answer dot end, right? Now let's observe that what is the what answer is going to come. Return answer. There is the end of the function, but there is one thing missing. What actually it is missing? Let's try to figure out. Let's try to run this for what? Let's try to run this for this 13, right? We have did the whole dry run for 13. So what should be the answer? The answer should be 1 3 5 13, right? Let's run this and see what the answer is actually coming. Okay, there is a compilation error, but it is saying that expected. Okay, there is somewhere mistake here. Right. Now run this code. Okay, it is accepting, but now let's see what is the answer. The answer is coming 3 5 13. 3 5 13. As you can see that 1 is not being included. Why this 1 is not being included? Because we are breaking our loop when n is not equal to 1. We are running till we are running our while loop till n is not equal to 1. So therefore, before sorting this, we have to first add this 1. So what we are going to do is answer dot push back what? Push back 1, right? And now let's try to run this code and let's see if the answer is coming right or not. So the answer is coming correctly. So with this, I hope the question was clear to you all. Code is here right in front of you. This is working perfectly fine. So I hope the explanation was also clear to you all. So thank you for this video. Let's meet in the next video.